Hey folks, the next group of functions, the next class of functions I want to talk about are the trig functions. So let's start out with a nice f1 equals the sine of x. So here's this familiar waveform. We know that sine of x passes through the origin. There it is there. Sine of x is an odd function. If I were to write y equals sine of minus x, then what have I done? I have actually flipped the function upside down. So odd functions have this special symmetry. There's the definition of an odd function if you like it. So let's calculate the derivative of the sine function, or at least let's have Desmos do it for us, and we get another waveform in green. So that shouldn't be too surprising. Since the sine function is periodic, it repeats every time we go a full way around the circle. Looks like Desmos is thinking in radians. Yeah, because we're wrapping around at 2 pi. There are 2 pi radians in a circle. So if the sine function itself is repeating every 2 pi units, it makes sense that its slopes are also repeating. So at this point, x equals 0, I've got a slope that's at a 45-degree angle. So that'll be a slope of 1. Here, at the peak of the sine wave, at pi over 2, that is a local maximum of the sine function. So that should be a point where the derivative is exactly 0. And in fact, we see that. So hey, that's another handy thing to remember, that we can detect maxima and minima of functions, or local extreme values, by looking at the derivative. So where am I going with this? What is this mystery green curve, this periodic function that's a waveform? It has, if you take x value 0, we get y value 1. Why? That is none other than the good old cosine function. So the derivative of the sine function is the cosine function. So let's continue and try to remember the derivative of the cosine function. So the cosine function I have here in purple, let's get rid of the red. So obviously I should have a derivative of 0 at this maximum here. I should have a derivative of 0 at this minimum here. Does that make sense? Let's have Desmos work on that for us. Have you figured out the shape yet? Why, it's another waveform. And in fact, what is this in black? It's the mirror image of the sine function. So what is that? That's got to be minus the sine function. So here is, that should be 3. Thank you. So the derivative of the sine function is the cosine function. The derivative of the cosine function is minus the sine function. And what's the derivative of minus something? It's going to be minus the derivative. So I'll tell you right now for free, the derivative of minus the sine function is minus the cosine function. So there it is in blue. So here I have a local maximum. Here's my my 0 derivative. Here I have a local minimum. Here's my 0 derivative. That's looking good. Here I have a negative slope, and I can see that because the value of the derivative is 0. And finally, what is the derivative of minus the cosine function? It is the good old sine function. So the trig functions have this strange story where they go in a loop. So derivative of sine is cosine. Derivative of cosine is minus the sine. Derivative of minus the sine is minus the cosine. And derivative of minus the cosine is back to positive sine of x. So that is a handy rule for differentiating these trig functions. So for my final video tonight, I will be talking about the exponential function and the logarithm function.